Hello and welcome to one-sided limits and piecewise functions. So we've already seen one-sided limits, primarily looking at the graph of a function, but you can also find one-sided limits just by looking at the function algebraic notation. So again, we've found one-sided limits of piecewise functions by looking at graphs. But we can also do so simply using the algebraically defined function. So for example, let's consider the function f of x equals 2x minus 5 if x is less than -2. X plus 3 if -2 is less than or equal to x is less than 3. 5 if x equals 3, and negative x plus 7 for x is greater than 3. And then our job is to find a series of one-sided limits. So first up, we're just going to look at x equals -2 coming from the left and then from the right. So as x approaches, as x approaches -2 from the left, so x approaches -2 from the left, then that means that the x values we are looking at are for x values less than -2. So we are looking at x values with x less than -2. So on this stretch, what we have is we have the function is behaving as 2x minus 5. So that means that f of x is behaving like 2x minus 5 for the values we are concerned with. So at this point, f of x is just 2x minus 5. Then what we have is we have the limit as x approaches -2 from the left side of f of x is simply the same as the limit as x approaches -2 from the left side of 2x minus 5. That is a polynomial, so we can simply go ahead and plug in. So we will take that -2 and plug it in for x. And we wind up just getting 2 times -2 is -4 minus 5. We get -9. Now, if we do the same thing looking from the right, so now we are looking as x approaches -2 from the right. So x is approaching -2 from the right. That means that we are looking at x values that are bigger than -2, but close to -2. So we're looking at x greater than -2, but close. So in our piecewise functions, that means we are looking at this -2 less than or equal to x less than 3. And so in this stretch, f of x is behaving as x plus 3. So our limit we are looking at x approaches -2 from the positive side of simply x plus 3. Again, we can take that -2 now and plug it in since we are looking at a polynomial function. And -2 plus 3 is just a positive 1. So again, coming from the right, close to -2, f of x is exactly the same as x plus 3. Since we are only looking at the right side of -2, and for limits, we are concerned with what is close to that value. Now we are going to do the same thing with the limit as x approaches 3 from the left versus from the right. So coming from the left, we have x is approaching 3 from the left. So we are looking at x values with x is less than 3, but again, we're close to 3. So if we look back at our piecewise function, we want x is less than 3, but close to 3. That means that we are looking at the same segment we were looking at earlier. Right? We want that x less than 3, but close to 3. That's -2 less than or equal to x is less than 3. And again, our function is behaving like x plus 3. So our f of x behaves like x plus 3 in that region. So we can go ahead and say that the limit as x approaches 3 from the left of f of x is the same as if we were just looking at the function x plus 3, looking as x approached 3 from the left. Once again, we can go ahead and simply plug in. We are working with a polynomial. Take that 3, plug it in, and we wind up with 6. And finally, we are going to do the same thing as x approaches 3 from the right. So here we have as x approaches 3 from the right. And we are looking at x values with x greater than 3. So if we scroll back up to our piecewise function, when we when we consider x greater than 3, that's that last row, and we have f of x is behaving like -x plus 7 when x is greater than 3. So at this area, f of x is simply acting precisely the same as -x plus 7. So our limit, we are essentially taking the limit as x approaches 3 from the right of -x plus 7. Again, that's a polynomial, so we can take that 3 and simply plug it in. And -3 plus 7 is simply 4. So for piecewise functions, when we're looking at left and right limits, simply find which chunk of or which piece of the piecewise function is relevant and then see what happens just with that piece. So this is finding limits of piecewise functions algebraically.